In continuation with the previous lectures on the gradient of a scalar and divergence of a vector, we will study in this lecture the curl of a vector valued function v. Initially, the lecture delivers the content for application and definition of v, curl v. Then finally at the end of the lecture, I have presented the physical significance of the curl. So go through the lecture and see the applications. Different examples have been taken so that you can understand the meaning and applications of curl easily, and also go to the last and don't miss the physical significance of the curl given in the last of the lecture. So what is a curl? Before we define the curl, we first remember that delta is a vector differentiation operator and defined by I del by del x plus j del by del y plus k del by del z. And in the previous lecture, in the last lecture, we studied that if phi is some scalar function, then del phi is called gradient of phi, and we also learned different characteristics of gradient of phi and different names. If v is some vector function, then del dot v is called divergence of v. And in the last lecture we also studied about divergence and took some questions also. So we are going to take the cross product here. So just I am reminding you that if a is a vector given by a1i plus a2j plus a3k, and b is another vector given by b1i plus b2j plus b3k, then cross product a cross b is defined by a determinant of which first row is I, j and k, the standard unit vectors. Then second row is elements of a1, a2, a3, and the third row is elements of b, means components of b. So b1, b2, b3. This we also learnt in the first introductory lecture, and now we will need it to solve questions. So now we are in the stage to define curl. The curl of v. Let vxyz is some vector function, vector valued function, then curl of v is defined as del cross v. So this is the definition of curl. Now let v is given as v1 x y z I plus v2 x y z j plus v3 x y z k. We assume that these are the components of v, and in particular v is a vector function, so let us write it as v x y z. For the first time, let v x y z is equal to, then because v1 v2 v3 are the component of vector v, so del cross b, as the definition we just wrote, is determinant I, j, k, then components of del, so that will be del by del x, del y del y, and del y del z. Then components of v, so these are v1, v2 and v3. This is precisely how we find the curl. So curl is del cross v, and this is the precisely method to find the curl. So we will take a question. to develop more understanding about the curl. And in a separate lecture, I will teach you what are the properties of curl and what are the physical and geometrical significance of the curl. So I will make a separate lecture on it and upload. So for the time, let us understand the evaluation of questions, problem solving involving curls. So as a very first example, let us find the curl of this vector r is equal to xi plus yj plus zk, just to learn. So curl of r is equal to I j k, then del by del x, del by del y, del by del z, and x y z. Now I have taken this example so that you can easily understand and expand the determinant. So you get I, then del y by del z by del y minus del z del y by del z, and this is actually del y by del z. So del del y del z by del y, yes, I written completely true, del z by del y minus del y by del z plus j times del z by del x minus del x by del z plus k times del x del y by del x minus del x by del y. So because all these are independent variables, so every partial derivative will become 0. This is 0, this is 0, this is 0, this is 0, and these all are 0. So finally what we obtain is this is equal to 0 I plus 0 j plus 0 k, and that means 0 vector. So curl of this position vector is 0. So you must remember this for the further questions. And now we will show that curl of r to the power r is also 0. Curl of r to the power n r is also 0. Where r is the same position vector we taken in the last example, xi plus y j plus z k. So in the introductory lecture and in the last lecture, we learned that if r is this position vector, then r square is given as x square plus y square plus z square. And remember that del r by del x is equal to x by r, and del r by del y is equal to y by r, and del r by del z is equal to z by r. We will need it in this example. So what is rn? What is r and r? This is precisely r to the power n x I plus r to the power n y j plus r to the power n z k. This is rn. So then what is curl of r and r? This is I j k del y del x del by del y del by del z, and r and x, r and y, r and z. So let us expand this. Expand, so you get I, then del by del y, r and z minus del by del z, r and y, and the two more terms will come, which I am leaving for you as a practice and homework. So this you will derive on the similar pattern I derived the first term. So this I, and what y will not differentiate z, so this is z times n r n minus 1. This is simple dot, not dot product, so it is multiplied by, so z n r n minus 1, then del r by del y, and del r by del y is y by r, so this is y by r minus this, so y and r to the power n will differentiate to n r n minus 1, then del r by del z will be z by r, and then the two other terms then that you will evaluate. So you can see that this both these terms cancelled out each other, and we get I 0 plus j 0 plus k 0, and finally 0. So curl of r and r, this is 0, where r is the position vector or vector given by this relation. And now we will show curl grade phi is equal to 0. So curl grade phi is always 0, where phi x y z is a scalar function. Whenever we take the scalar function and its gradient, the curl of the gradient is always 0. So first we know that what is grade phi. Grade phi is I phi x plus j phi y plus k phi z, and phi x means del phi by del x, phi y means del phi by del y, phi z means del phi by del z. So what is curl of grade phi? Curl of grade phi, this is given by the determinant I j k and del y del x del y del y del y del z, and in the final row phi x phi y phi z. So it is very easy to observe now that I has del phi z by del y, del phi z by del y minus del phi y by del z, and here again I can leave the two remainder terms for you as homework, because it is not tough to obtain. So this way you keep your practice, you will make your practice, and you will understand more deeply. So now you can see that I component becomes phi yz minus phi zy, and because these we assume that the phi xyz is continuous function, so this and plus j times some component and k times some component, and these are equals phi yz is equal to phi zy, means basically what is phi yz? Phi yz is basically del 2 phi by del y del z, and similarly phi zy. So these are equal and therefore cancels out each other, and we finally get this I 0 plus j 0 plus k 0, and that is a 0 vector. So what we obtained is curl of grade phi is always 0. So remember it, we will use this result in further questions. Now we describe a property. There is a particular name when curl is 0. So properties, the name is rotational vector, and we say that a vector v is irrotational. V means v a function of x, y, and z, not constant vector. Function v is irrotational if curl of v is 0. If curl of a vector is 0, we say that vector is irrotational. And rotational just means that a fluid, a physical particle rotate about its own axis. So we will understand it in a separate lecture, and just here know that if curl is 0, then vector is called irrotational. So if vector is rotational, and in last example we saw that curl of grade phi is always 0. So relate these two things. Curl of grade phi is always 0 and curl of v is 0, then v is rotational. So it means for this implies for all vectors v such that curl v is equal to 0, there exists a function phi x y z such that v is actually equal to grade of phi. Means whenever v is a rotational vector, you can say in other words that whenever v is a rotational vector, for every irrotational vector v, there is a scalar function phi such that v is equal to grade phi, and obviously curl v is rotational, so curl v is equal to curl grade phi is automatically 0 because we have already shown that curl grade phi is always 0. So now we will solve. So let phi x y z be some scalar function. From the total derivative, we know that the differential d phi is equal to del phi by del x dx plus del phi by del y dy plus del phi by del z dz, and this can be written as del phi by del x I plus del phi by del y j plus del phi by del z k dot product with dxi plus dyj plus dzk, and you see that this first bracket forms gradient of phi and the second one is dr, means d phi is equal to grade phi dot dr. So if we integrate d phi we can get phi. So integrating both the sides, we get phi is equal to integral del phi dot dr plus a constant. But if v is a irrotational vector and v is equal to grade phi means del phi, so we can write this v dot dr plus c. So this is how we find this scalar function. So whenever vector v is rotational means its curl is 0, it can be written as v is equal to gradient of some function, and that function phi can be obtained by this formula. So let us do a question and find this phi. Show that v is equal to 2xyzi plus x square z plus 2y j plus x square y k is irrotational. Also Find a phi x y z such that v is equal to grade of phi. So we will find this function. So the first thing is that we should show that v is rotational. So for that, how will we show that v is rotational? Find its curl. So I, j and k. Curl is 2xyz, then x square z plus 2y, then x square y, and sorry, this line will contain the operators. This line will contain the operators. So del by del x, del y del y, and del y del z, and finally in the last row we have 2xyz, x square z plus 2y, and x square y. So this is very simple determinant, and you can open this and you will get 0. So because curl is 0, the vector v is irrotational, and this implies v is irrotational. Just open the determinant and you will see that every component is separately 0. Now the main problem is how to find this phi, and this implies there exists a function phi of xyz such that v is equal to grade phi. So how we find the grade phi? We have already seen the formula. So phi is given by integral v dot dr plus c. So let us now integrate this to find the phi. V, this phi x y z as per our formula becomes 2xy z I plus x square z plus 2y j plus x square y k. This into what is dr? Dr is dxi plus dyj plus dz k, and a constant of integration. So you can write it as 2xyz dx plus x square z plus 2y dy plus 2y dz plus the constant of integration. So here is a trick to integrate it. First integrate this integral and let us say it x integral, just for the name. So first we will integrate this integral, and why I am saying x integral, this is integral with respect to x. So let us say it x integral. So integrate with respect to x and keep y and z constant. This is it to integrate. Otherwise you can integrate directly and will become hectic. And now integrate only those terms, integrate only those terms integrate only the terms which are free from x. Integrate only terms free from x, and finally integrate the terms free from x and y both. Means in first integral we will just integrate with respect to x and keep x and y constants. So let us do this. So x, y and z are constants. So integrate 2x, we will get x square y z plus, in the second integral or y integral, integrate with respect to y, but if a term contains x, leave it. So first term has x, so leave it. Second term is purely in y, So we have to integrate the terms that are free from x, means second term will be integrated. So this is y square, and then in the third integral, integrate only those terms which are free from both x and y. So this contains y, so leave it. So finally this. So this is our phi x y z. This is the standard technique to integrate and find y, and you will learn the technique in the next semester and under exact differential equation. So this is how we find. Now we will prove some identities involving divergence and curl of vector and gradient also. But before that, let us try to understand some shorthand scheme. So you know that if we write sigma n is equal to 1 to 10 x and an, what does this mean? x1 a1 plus x2 a2 plus x3 a3 plus up to xn an. If it is understood that the upper limit is fixed to 3, then we do not specify the upper limit and just write the lower limit. So this sigma n is equal to 1 to without upper limit x and n is this. And if it is also understood that this subscript index n will always start from 1 and always end at 3, then we do not write any limits upper and lower, then just sigma x and n is this. So consider the vector r is equal to xi plus yj plus zk. Let us write this in the form x1 i1 plus x2 i2 plus x3 i3. Then we can write it in the upper convention xn in. So because it is understood that vectors are maximum up to 3 components and start from first component. So there are always 3 component of vectors in 2 dimensions. You take third dimension equal third variable 0, means coefficient of I3 a coefficient of k, this is equal to 0. So it always has 3 components. Vector is basically defined with 3 components. So we have 3 components. We denoted x as x1, y as x2, z as x3, I as I1, j as I2, k as I3. Then this can be written as this summation, because it is now understood that it will start from I1 and at I3. So now why should we use this summation convention I1, I2, I3? Let us write this as sigma, this as sigma xi, and it should be now understood that the two more similar terms means plus yj plus zk will be there. Similarly, so we can write r vector as this form. Similarly, now we can write delta I del by del x plus j del by del y plus k del y del z as sigma I del by del x. So this is the shorthand. This is the shorthand for r. This is the shorthand for delta, and we will use similar shorthand. So del phi can be written in shorthand notation I del phi by del x. So we will now use this shorthand notation to prove some identities. So let us prove the first identity. Divergence of u cross v is equal to v dot curl u minus u dot curl v, where u and v are vector functions. These are vector functions. So let us prove this. So we will use the shorthand notations. Divergence of u cross v. This can be written as sigma I del by del x dot u cross v, and keep it in your mind that this dot is not due to del by del x. This is due to I. So del by del x can be moved both sides from left to right and right to left of the dot, but I will remain at its position. So this can be written as sigma I dot del u by del x cross v plus u cross del v by del x. Now we will get two different parts, sigma I dot del u by del x cross v plus sigma I dot u cross del v by del x. Now we will use the vector identity, namely A dot B cross C. So how do we write this? So you know that A dot B cross C can be written as B dot C cross A, and in a circular form, and that is equal to C dot A cross B. So we will use this to rotate this one, and you will, after writing, you will understand why I am rotating this. So you can take basically I and del by del x will be finally kept together to form the summation convention that we have discussed. So we can start from B, as you can see started from C then ended with V. So we can start from V. So this can be written as V dot sigma I cross del u by del x. And similarly, in the second one, you can first rotate it, so you can write it sigma I dot del v by del x cross u. Then we will do the same process I done in the first one. So we can write it v dot sigma I and del by del x cross u. You can see that I del by del x has come together and it will form the delta. So this will become delta cross u. This is basically delta cross u, and v is outside. So this we have obtained. Now similarly, in the second form, we will obtain this as u cross, sorry, u dot u dot sigma I del by del x cross v, and this has become u dot del cross v, and this is curl u, this is curl v. So we have obtained this is equal to, means divergence of u cross v. We have proved it, this is equal to v dot curl u minus u dot curl v. This is, we prove, you can also show v dot del cross u. We have already written it, minus u dot del cross v. We have already written it, but during examination you can be asked to show this, you can be asked to show this, so don't get confused and prove this. Similarly, let us take another example. Let phi x y z be scalar and u x y z be vector. Then del cross phi u, what is this? So let us start our shorthand notation. You can do it in expanded form also, but it is easier. So this I del by del x phi, this cross phi u, and del can be taken inside the bracket, so we will get this as sigma I cross del phi by del x u plus phi del u by del x, and we can finally, so we can write del cross phi u as sigma I cross del phi by del x u plus sigma I cross phi del u by del x, because phi is a scalar quantity and summation does not runs for phi, summation runs for I and x, so we can take this phi outside the summation, and this is similar as you take alpha fx, then you take alpha outside the integral. So let us do the same thing. We will take this phi outside because this has no role in summation, so we will get this, and in the first one, so let us first write the second one, then we will simplify the first one. This is del phi by del x u plus phi times sigma I cross del u by del x. Again, you can take this, you can please have attention, pay your attention here. Del phi by del x, phi has nothing to do with the summation, but del phi by del x means del phi by del x, del phi by del y, and del phi by del z will be there. So because this is scalar, this has nothing to do with the cross product, so del phi by del x can be taken on the left of cross, so we will get this I del phi by del x cross u and plus phi, and you can see that this can be written as I del by del x cross u, and now this is del phi cross u, and this is phi del cross u. So we have proved del cross del cross phi u is equal to del phi cross u, and phi del cross u means you can also say grade phi cross u plus phi curl u. So this is the identity we proved, and you can prove it in expanded form. If you consider the expanded form, you will have to write I del by del x plus j del by del y plus k del by del z, and the cross product taken with phi ux I plus phi uyj plus phi uzk, and then you will conclude the same thing. So I am avoiding this extra notation, just shorthand notation. Once you learn it, it is very easy, and you should practice it. And now we will prove that divergence of curl of a vector v is always zero, where v is a vector function. So let us prove it, and also remember this. So first we find curl curl v, and we assume that v has the component v1 v2 v3, so del by del x, del by del y, del by del z, and v1 v2 v3. I am not using shorthand convention here because this convention will lead to confusion due to double operator del and del. So this can be written as I del v3 by del y minus del v2 by del z minus j times del v1 by del z minus del v3 by del x plus k times del v2 by del x minus del v1 by del y. This is our curl v, and now divergence of curl v, you know you have already obtained divergence, so this will be del by del x of the first component, del v3 by del y minus del v2 by del z minus second component del by del y del v1 by del z minus del v3 by del x plus third component del by del z del v2 by del x minus del v1 by del y, and just open these del v3 by del x del y, and the same thing del v3 by del xy will come from this part del v3 by del x del y. This will also give del v3 by del y del x, and now del v2 by del x del v2 by del x del z minus del v2 by del x del z. You can open all this, and finally del v1 by del y del y del z minus del v1 by del y del z all equal to 0. So we have just proved that divergence of curl v is always 0. So you can symbolically also write it as del dot del cross v is 0. Sometimes you may be asked to prove this in the examination, and sometimes you may be asked to prove this in the examination. So keep in mind that things can be written in notation and written in words. Initially, I prepared the lecture for the applications of curl only, but at the last, when I saw that there is a time that I can extend the lecture, I decided to put the significance of the curl here. So let us discuss the significance, physical significance of the curl. So we discussed throughout the lecture what is the curl. So we know that if if v be the linear velocity, omega be the angular velocity about an axis, and r be the position vector of a point x, y, z. Of a point x, y, z means a point at which the angular velocity is omega, linear velocity is v, and its position vector is r. So we are all the three things are taken for a particular point. So if these are the things, you already know that we know that v is given as r cross omega. Now let us write these in components. So let r be given as xi plus yj plus zk, and omega be given as omega 1i plus omega 2j plus omega 3k. Then what is r cross omega? R cross v is equal to r cross omega, and that is given by the determinant I j k x y z omega 1 omega 2 omega 3. So you can find this is equal to I times y omega 3 minus z omega 2 minus j times x omega 3 minus z omega 1 plus k times x omega 2 minus y omega 1. Now we will find what the curl V becomes. So by the definition of curl of V is I j k del by del x del by del y del by del z and the components of V. So we have just obtained the components of V as omega 2z minus omega 3y, and second component is omega 3x minus omega 1z, and the first component is omega 1y minus omega 2x. So you can again open this determinant, so you will get I times, and you can say this minus this times, so del by del y omega 1 by del 1 bracket I am writing in full, and other will be written similarly. So del by del y omega 1 y minus omega 2 x minus del by del z, and we have omega 3 x minus omega 1 z and minus j times. So you can observe first that what comes from the first bracket. So let us write that explicitly. So that will become I, and y will not differentiate omega 1, neither it will differentiate omega 2. So this omega 2 z, so this will come out to be simply omega 1. So this becomes omega 1, and then z will differentiate z only. So minus minus this minus and this minus plus, so we will get again omega 1, so 2 omega. So similarly in this second bracket we will get omega 2 plus omega 2, and the third bracket means along k we will get omega 3 plus omega 3. So finally what we got is I plus j 2 omega. This is minus omega and this is also minus omega. This minus omega 2 and minus omega 2. So finally what we got is I this omega 2 plus omega 2 plus k omega 3 plus omega 3, and every component is twice, so we can write it 2 times I omega 1 plus j omega 2 plus k omega 3, and you know this is just omega, so we got 2 omega. So what we got is curl of V, curl of V is equal to 2 omega, and that simply means that omega is equal can be written as half of curl V. So this is the straightforward formula and a relation, either this or this one. This is the straightforward relation that we established between omega and the V, linear velocity and angular velocity. So if omega is 0, curl V is 0, means we simply decide if a vector is rotational or not rotational. Omega is angular velocity, so if a vector contains angular velocity, it has rotational velocity, and if omega is 0 means curl V is 0, the vector has no rotational velocity. And these things are especially for fluids like liquids or gases and these things. So and otherwise these also come in force for magnetic field, electric field, and gravitational field also, but basically the velocity term is used for flow only. So anyway, when curl is 0, there is no angular motion. Vector has no angular part. So we say that if curl V is 0, therefore we say that if curl V is equal to 0, then vector is called irrotational. That is, if curl V is equal to 0, we say that V is irrotational, means rotational part is absent from the vector. This is the physical significance of curl. So as a summary for this series of vector differentiation lectures, we uh, covered the topic on vector gradient of scalar field, then divergence of a vector field, then curl of a vector field. In the course, we also studied the physical significance of gradient and curl. The only thing that remains is to put the physical significance of divergence, which I could not include in the lecture of divergence because of the length of lecture. And if you are interested, you can put in the comment and I will upload the content as a separate lecture. By the time you should enjoy the lecture and study and learn and keep in contact. In the next lecture we will start very interesting topic, vector integration, and vector integration has a lot of applications in the calculus. Thank you. Stay connected.